Do a self-quiz. For each problem, sketch the region instead of the integral needed to find the volumes. Do not solve them. So you don't have to solve these. We're just going to set them up. This is self-quiz. I don't need to solve it. Find the volume of solid obtained by rotating the region bounded by y equals 3x minus x squared and the x-axis about the x-axis. So y equals 3x minus x squared. So that's probably facing down. Now with this one, I probably want to find the x-intercepts. So let's set this equal to 0. So I find the x-intercepts. It's got to factor it. They both have an x. People always freak out when it's just like a binomial instead of a trinomial. They both have an x. Factor that out. Equals 0. Split it. X equals 0. 3 minus x equals 0. So I get x equals 3 and 0. So we're going to have 0 and 3. And it's again, it's not a perfect graph, it's a sketch, so it's a negative x squared, so I know it's opening down. So something to this effect. Right, and then we're also doing the x-axis. And we're going to flip it across there. So this is a disk method. Don't have to write that anywhere. They're never going to ask you that question. But it helps us know the formula, which is pi big R squared dx. And we're going from 0 to 3. So what's my R? Top minus bottom. So it's going to be 3x minus x squared minus 0. So just this guy. So pi integral of 0 to 3 of 3x minus x squared dx. Again, no need to solve. That's our answer. The next one. Sorry. Find the volume solid obtained by rotating the region in the first quadrant bounded by y equals x squared plus 1, x equals 3 about this. Okay, so x squared plus 1 looks like this. Ish. I don't like that picture. A little better. And x equals 3. So 1, 2, 3. So like right here. In the first quadrant. So we're talking about this guy right here. That's a little region. Now they want to spin about the x-axis. So this guy. Easy enough. That's like a disk method. We're just going to do integral. So in this case, my r is going to be x squared plus 1 minus 0. So we're going to do pi from 0 to 3 of x squared plus 1 squared dx. Again, don't need to solve it. There's my answer. Next, though, y equals negative 2. So this guy's gone. Now we're going to spin across y equals negative 2. So right here. Now again, it's still bounded by the first quadrant, so it's right there. We're spinning around there. This would be a washer method, right? So it's y equals negative 2. So I need to find the big R. So there's this guy and there's this guy. This one is a big R. Big R is going to be x squared plus 1 minus the thing you're rotating against, negative 2, which gets me x squared plus 3. Little r will be this guy, and that's going to be 0 minus the thing we're rotating against, negative 2, so that's going to be 2. So my formula here is going to be pi integral from 0 to 3 of big R, x squared plus 3 squared minus little r, 2 squared dx. And then the line y equals 10. So let me erase those so that doesn't confuse you guys. Ish. We'll do this in light blue. So let's say 10 right here. So again, same idea, need bigger or lower. So all we do is draw a line to connect both lines. So we have this one, and we have this one. That's kind of like a line. So I have a big R. Number big R here is this guy. And with that, that's 10 minus 0. It's just 10. And then we have a little r right here. And what is that? Top minus bottom. That's 10 minus that equation, x squared plus 1. So 10 minus parentheses x squared plus 1. Or for the ease, that would be 9 minus x squared. So my formula here is going to be pi 0 to 3 of big R, which is 10 squared, minus little r, 9 minus x squared dx. And that's a self-quiz.